because the volatility we use, the realized volatility we use, is not the traditional volatility that you have on the market. We have a different type of volatility measure called the gamma capture. And we think this gamma capture has a better predictive power. So we'll probably uh, try using gamma capture to predict volatility and create an arbitrage strategy. And that's what we will be working on. And yeah, I think it's going to be interesting.
Okay. Tanya, any thoughts on that?
Okay. So for this project, our first step is writing a paper exploring how we're going to use because essentially since we're exploring, we don't have a trade signal yet, so we want to look more into that and see if we can establish a trading signal, and then afterwards we can see if it's tradable, and if indeed it is a better predictor, then we can use it to do our trading strategy. So yeah, that's essentially what we're working on. So the first step, we were tasked to find out if we had access to data from Bloomberg, and also if we have enough computing power to carry out the tasks. And we'll be using statistical models such as Arch and Gauge to look more into the volatility. So yeah, that's essentially where we're at.
Yeah, and just to like update you on Louis, we got
Yes.
I sent you an email the other day. We got the data, like the SPX and VIX data, 60 minutes and 20-minute ticks for about 120 days. Rob wanted 10 years of data, but Bloomberg only gives us 120 days, 120 trading days of data. So if we can work with that, I guess like we can try setting up the structure with the data that we have and maybe expand it.
Yes. That's a good start. There's other data sources that are free, but maybe the data is not as accurate. But at least that's something to consider as well. There's a site called Dukoscopy. They give you free tick data, but it's free, so you don't know. It works. We've done we're getting together several years of gamma capture realized vol intraday using their data, so it's a starting point. So I think you're right. Just to get started, maybe the data that you have is a good place to look, and then after you have the structure of the data, it's not that much difficult to switch it out for a different data set.
What's the name of the site?
Dukoscopy, Dukascopy. Dukoscopy is it's a European bank, and there's a historical data portion of their website where you can download as much data as you like off their site. So yeah, I can send you that information so that you guys can have a longer data set. But and then the second thing is, the prediction of forward intraday realized volatility. There's several models that can be applied for that. Even machine learning, if you guys use something like a random forest, it doesn't necessarily have to follow Garch. It can, and then even within Garch, you can pick your parameters that you want to predict. So model selection, I guess, is a big portion of this, just so that you have a model that you understand and that you can evaluate afterwards. I think is more important. I think than there's a lot of learning steps in this project. I mean, it's a pretty involved project. So I don't know, Professor Zorro, if the learning is part of it, or if there's actual signals, even better. But learning how to pick the right model, evaluate it, get the data cleaned. Those are all hugely important.
Yes, I mean
Um,
usually what the student will do is they'll pick, and I don't know if they've done that already, but they'll pick a paper.
mhm.
Tanya, do you guys have a paper yet, or to go by?
We have a reference paper that we're
Okay,
looking
okay.
at.
Yeah.
The Guyan Garch model is very complicated the more you dig into it. So I'm suggesting maybe a simpler version of that, just so that the results are more and the calculations and results are more understandable. Because his is, you know, his is a very, at the end of the day, it's a lot more complicated than than it's a good framework, but it's you know, I would caution against trying to replicate what he's done. It's just a very complicated model. It's very sophisticated, and but we could use a similar version of a Garch. And you know, when you look at the SPY intraday volatility, there is a pattern for sure. Intraday volatility goes up to 10:30, and then it goes back down to 2 p.m. And it stays pretty flat. So that's SPY is what we're looking at, the S&P 500 ETF index, symbol SPY. So we've already determined a pattern, an intraday pattern for realized vol. It's very consistent. And the question is, you know, how accurately can we forecast that for the next day? And, you know, again, the model selection is very important. It can be a Garch, but again, you could be a machine learning random forest. I know a lot of this code is already available in R and Python, so you don't have to reinvent the wheel. But if you're gonna try to reproduce Guyan, I would think that would be a lot more difficult. You know, I would start with a more basic Garch model, than to jump right into a very sophisticated one. So if that makes sense.
Yep, yep. Okay. So, so I think we're meeting every 2 weeks. I think we can discuss like what are the steps, what are the things that we can do within the 2 weeks so that we can get this thing going, right?
Yes. So, and then getting back to the signal, if you knew perfectly well, let's just assume you knew 100% what next day intraday realized volatility looks like. You know, I would suggest saying, okay, what would a zero DTE option price be using the intraday realized vol prediction into the Black-Scholes formula? What would that yield you as a premium? You know, you put in the volatility, you get back a premium, and then compare those premiums to whatever premiums have been traded on that day in the SPY zero DTE. Does that make sense for a trade signal? It's to see if our volatility gives you a good price for the options. If S&P options are priced higher in real, you know, in the actual market than not. So we don't have the we don't have options data. Maybe that's where you can go back to
Bloomberg.
the date. Yes, yeah, the data provider, and see if you can then say, okay, we have a prediction of next day realized volatility. We're using that next day realized volatility to price these zero DTE options. These are the premiums that we're getting throughout the day. Maybe just do it in an hourly basis, make things easy. And then on each hour, this is what we see the premium as our prediction of what the premium should be.